Okay, so today's presentation is about adding basically some web technologies to GStreamer as libraries. What we're going to have is the media source extensions and the encrypted media extensions, like how you can get those into GStreamer. That's what I'm going to discuss. So about me, I'm a software engineer at Collabora, working on GStreamer stuff there since probably April 2022. Before that, I worked at places like Amazon and a couple smaller companies over the years. Mostly in the past, I've been doing stuff like digital print automation, some GStreamer stuff, some Linux audio drivers, and then like some web service stuff, some generic stuff. Currently based in Fort Collins, Colorado, USA, originally from Los Angeles area. That's pretty much it for me. So the overall agenda is going to talk about what media source extensions are, what encrypted media extensions are, and then kind of how it was implemented in GStreamer. And then challenges, and maybe we can demo some stuff too. So, yep. So what is the media source extensions? It's basically web technology. So on the web, you can play videos. Everyone can do that. What's complicated is there's only a couple of protocols supported by like the media elements. What if you want to just put your own code? What if you want to put your own videos in there? So how do you do that? There's basically a specification called media source extensions that allows programmatic input. So any like JavaScript application you write, you can append media to this using this API, and you can do playback with it. And the way it works is, as the media comes in bytes, it's basically parsed, and it's parsed into like something you'd get in a regular GStreamer program. So it's like it parsed and demuxed into the format that it comes in, but it's ordered and time addressable. So it goes into data structures where other components can play it back. The specification requires that you support a certain set of formats. So one of them is fragmented MP4 that you heard of before. Also WebM, MPEG TS, and MP3, and basically MP4 audio. Those are what's supported. Yeah. So that's what you can do with it. What's basically the data model of media source? The first thing you have your HTML media element, which is video, audio, whatever. That's responsible for the playback. The next thing is the media source. Like that's just kind of like the entry point, a placeholder for what organizes all this stuff coming in, and how you link it to the playback. The next thing is a source buffer, which is actually where all the real stuff happens. It's fairly simple to use. A source buffer represents basically one stream of media. So if you have a single file that you're trying to represent, it would take basically a single source buffer. If you want to combine like the audio from one file, the video from another file, you'd have two source buffers. And then your application would have to, produce data into them simultaneously. As you append data to each source buffer, it's basically processed by the multimedia system in GStreamer to produce like those time-coded samples and order them in the track buffers. Track buffers is basically for each track you find in the audio or video stream that you're putting into the source buffer, they're now segregated by whether it's video or audio, and they're also addressable by the kind of track. This gets a little more complicated because if you have multiple source buffers, what's going to happen is you're going to have to basically select which video track you want to use, which audio track you want to use. So there's a big group of stuff, and then this kind of structure provides like an organizing mechanism. So that's basically what the data model is. If you want to look at the structural relationships, basically how these things are linked up, this is basically it. So the application is responsible for creating the media player and the media source. And there's kind of like a parent-child relationship between the media source buffer, and the track buffer. So media source is going to have one or more source buffers, and as source buffer processes data, it's going to create all the tracks necessary, whatever's in the media that you're providing. So the next thing we're going to talk about is what's the data flow? What happens when you send data into the source buffer? So it kind of went over it a little bit, but basically the raw data goes in, which is basically like a video file, audio file. It can be, like, the interesting parts about it is that you can basically be procedurally generated or just be decoded from something like a dash manifest or whatever. That's kind of what web applications do sometimes. Like there's things like Shaka player for JavaScript that will basically take a dash manifest, turn it into a stream of MPEG content or whatever, and it uses MSE API. And then as the source buffer processes stuff, it's gonna create the track buffers as mentioned, and then the track buffers, those are going to be used to actually do the playback. So the media player is going to it's going to be fed by all the selected track buffers, and that's going to produce your audio and video output and text as well. Okay, so next topic is like what is the encrypted media extensions? If you've never seen that, basically it's if you ever used one of those online streaming services that provides copyrighted content, and that's legal. You probably used encrypted media extensions. It basically is the link between a digital rights management system and your web browser. So it was developed basically for that purpose. The specification itself, if you haven't seen before, it basically defines how the main components should talk to each other and like what their roles are. So the application is basically what is producing the content and intending to play it on the screen or whatever. License authority is typically it's like a web service owned by the rights holder or the rights provider, whatever you want to call that. And then the content decryption module is software on the device. That's typically like some secret stuff that prevents users from figuring out how to steal the media, basically. That's the goal of it, at least. And the EME basically supports MP4 as a container and web app as a container. The actual stream of content is described in the common encryption CENC, if you've seen that before. It's basically AES encryption, and there's a couple of varieties of it. The point of this is that there are multiple DRM systems, and you don't want to have to encode the same encrypted media for a bunch of them. So this scheme allows you to basically allows multiple systems to decode the media if they have access to the correct keys. So within the important feature about this scheme is that there's a concept called initialization data, which is within the byte stream of media, it will tell you what keys you need to decode the upcoming segment of media, and that basically drives the whole playback and decryption process. The standard also specifies something called clear key, which is kind of a test decryption system where the application actually can see the decryption key. So it's useful for integration and stuff like that, but it's not like a commercially viable solution. And then the final thing about it is the web browser, like if you use Firefox or Chrome, it's going to include a commercial CDM. So that's going to actually handle what services you pay for are going to be using. So like for example, for Chrome or Firefox, they're going to have one of Google's Widevine CDMs distributed with it. So the data model for the EME is kind of minimal. There's something called the media key system access, which basically doesn't really do much. It allows you to actually get access to the CDM. Media keys is actually kind of like a one-to-one mapping between the CDM instance. So for every CDM that your browser supports, you're probably going to be able to access one media key object. The session is actually where most of the work happens in terms of the application interaction. The session represents a set of keys that you need to play the upcoming segment of media. So it's going to say, like, okay, this part needs key A, B, and C, and then the system will have to figure out how to handle that. So this is the kind of like the structural setup of EME. Basically, what happens is the application has to create a media player, and then within that media player, you're going to need some kind of decryption system set up in there. On top of that, as the application plays back media, you're going to need to link it to the CDM so it can basically request the keys, and their decryption component can decrypt the content using all those data that it gets. Data flow is kind of more interesting because it's about kind of the isolation of responsibilities, like what each component in the conversation is supposed to do. So this is kind of where it's a little, there's a little bit of ambiguity here, but basically the point of this all is that you want to limit what the CDM itself can do because it's on your computer, it's code that you don't trust, so it shouldn't do things like talk on the network, stuff like that. The session itself is something that the application is going to interact with to try to get keys when the decryptor needs the keys. So as you're playing something, if the decryptor encounters some, like the initialization data, and you don't have a key for it, you're going to need to go find the key somewhere. You're going to either load this from a disk, if you have something called a persistent session, or you're going to try to get it from a remote license authority. So what's going to happen is first the CDM is going to notify the session, produce an event that the application is going to have to process. The application is going to have to process this by calling out to some license authority somewhere, web service, and get a response containing some version of the keys. That's typically going to be encrypted, basically hidden from the application. And then the application is going to have to send that back into the session. Once the session has it, then the CDM has access to it, and it basically gets pushed down back into the session and back into the CDM, and the CDM can handle it. All while this is happening, the decryptor element is going to be trying to send the encrypted samples into the CDM to get them decrypted. What happens at that point is actually it's kind of specific to the CDM. As they get more advanced, they're going to do more things. So basic CDM, if you look at like the clear key one we talked about before, or the least secure widevine one, you put the media in, the encrypted media in, and you actually get the encrypted media out. The more complicated ones they're gonna hide basically more. They're gonna hide more of the decrypted stuff from the overall system. But that's basically different for every application. But you can imagine that that some actually can also, the decryptor would also be like a video sync or something. It would handle all that stuff. Okay, so next thing we can get into is what exactly did we do for the MSE library. So for this, what's the point of it, first of all? The point is that you can, it would allow you to take advantage of existing software that uses the MSE API without actually having a web browser library in your code. That's kind of what it would do. Where it comes from is actually WebKit already has a GStreamer-based MSE implementation. So the process was basically porting that to plain C or GObject C and removing all this other stuff. In the end, the way that this actually works is that the source buffer includes its own little pipeline. Each source buffer includes a pipeline, and that pipeline ends up, doing all the parsing and the organizing of the samples. And all it relies on is actually basically three things: app source, which is basically what a media source is in the first place, and then parse bin, which so the app source you put in the raw bytes, you link it to a parse bin. The parse bin pulls apart all the media, and then the app syncs allow the the source buffer itself to receive the media and put it into the track buffers. The next thing we did is adding a source element, because when you have all this data, you actually need to actually enqueue it into the playback system. So just a custom source element that first handles the MSE URI scheme, which allows you to just hook it up to a play bin. And then another thing it does is it figures out which tracks are selected, and it plays those tracks only. So like I said, you can integrate it with Playbin or GST Play, and that's typically how applications are going to use it. The overall process for application uses is create a pipeline, set the URI, and then during the setup process of the pipeline, you're going to create the media source, attach it to the MSE source. There's APIs in the library to do all this stuff. And then as needed, you're going to add source buffers to the media source. You're going to play the pipeline, and then you're going to feed the data into the source buffers. That's basically like all the interaction. There's a fair amount of events that happen, but this is the basic functionality. Let's see. Next thing is, so we're going to talk about what exactly is in the EME library for GStreamer and why it exists. The first thing is, if you look at what GStreamer supports now, it has a lot of the underlying frameworks for figuring out what is encrypted in the media, like how to deal with encrypted media, but it doesn't actually know how to play them back. There's no decryptor element, at least that I know of, that's in the main tree. So what happens now is when you try to play back media in GStreamer that's encrypted, several of the demuxers they're gonna raise an event saying that this media is protected, and they're going to tell you about it. It's basically an analog to the initialization data that we talked about earlier. It's kind of the same thing. So currently in GStreamer, MP4, WebM, MSS support producing these events and tagging each buffer that's encrypted with the metadata. Like I said, there's really no real decryptors in GStreamer right now. There's like a test one somewhere, but it's in the source code. It's basically doesn't really do anything. So for that and for all this, we basically implemented a library in GStreamer that maps to all the concepts in the EME specification. So the EME library, it's basically interfaces and a couple of data models representing states and stuff like that. The next thing we actually did is there's a little bit of complexity with how you actually can enter, basically the entry point for the EME API. When you're developing web applications or client-side web applications, you actually request the system access object from, I think it's from the browser, it's like a navigator.something API. So that doesn't really exist in GStreamer. What we have to do, or what we decided on, is actually create kind of like a fake element that has a little action signal API that you provide those arguments to, and then if the configuration that you've asked for can be satisfied by the EME stuff you have installed in your computer, it will return back the system access object. So that's kind of the convention. It's not necessary for every implementation, but it's kind of something that can be followed, and that would basically allows the entry point into the EME API from each implementation of the EME API. If you look at the EME API in JavaScript, or in the specification, a lot of the methods return promises. So we just rely on the GST promise API, and it matches up pretty well. Instead of returning a promise, you typically supply a promise as an argument, and the caller just waits on the response. That's the main difference. So, next thing I can get into is like what exactly does how exactly does an application use this? It's more complicated than the MSE example, just because there's a lot more stuff going on. So the first step, similar to before, you set up a pipeline with a decryptor element. The easier way is just to use GST play, and if your plugin is set up properly, based on the auto plugging, it'll actually be able to find it, and you won't have to do much. But yeah, it takes a little bit to get there. Aside from that, the application is responsible for actually setting up the EME, like the EME kind of side of the problem, which is like the media key system access, the keys. Those are the first two things you're going to set up. Those are kind of mandatory. You can do them before starting your playback if you know what protection system media uses. Otherwise, you can respond to the events that come out of the pipeline. So when you don't know what's going on, when you don't know what's coming into your application, there's going to be a message that says like a need context message, and your application can respond to that by creating those things. Otherwise, you can have them preset beforehand and insert them into the pipeline as necessary. The next thing that's going to happen is every time you encounter encrypted media, there's going to be an event, a message coming in on the bus, basically providing you with the initialization data. That will have to be processed by the application. It's going to trigger some stuff in the EME API, like the application is responsible for doing that. The EME API will actually send messages back, and then those have to be processed further. Typically, this is going to be happening with like requesting a license. That's the simplest case. The session is basically going to request a license for each key that it needs, and then the application is going to request those keys from the license authority. And all these things have to happen basically as responses to the events happening in the pipeline. And then once the response comes back from the license authority, the application sends it to the session, and the session will populate that information in the CDM. After that point, the CDM should have enough information to decode the content. So the next thing we can discuss is, okay, what if I have a CDM and I want to actually integrate it into GStreamer? How do you do this? So there's a couple options. One of them is write your own plugin. This is probably the most flexible option because you can use all the details of the EME API, but it's also probably going to take you more time. So basically, you implement all those interfaces, and this is all going to be like specific to the CDM that you're writing. So it's going to require knowledge of how to use it and everything like that. Let's see. Another thing you're going to have to do is actually implement your own decryptor, because how do you decrypt the media if you don't know the keys? This is all something that the CDM itself needs to figure out how to do. So those are the things that you're going to need to do if you want to write a plugin from scratch. Another thing you can do is actually there's an existing project for GStreamer called Sparkle CDM, and this basically, if you've ever seen something called OpenCDM, it's kind of like, it's very similar to the EME concepts. It maps almost one-to-one, very close. And we can just wrap that and adapt it to the EME API. And anything that works with OpenCDM should be able to work with this EME API. So that's another option. And there could be some other options too, but those are the two that we're going down right now. So I can provide one example of actually kind of taking the wide-band CDM that comes with the web browser and sticking it into GStreamer, see what happens. So I actually did that, and it's able to play back encrypted media with wide-band CDM inside GStreamer with no web browser. Yeah, and the path I took was actually using the Sparkle CDM. Not for any specific reason, mainly just to do it quicker, because Sparkle CDM already has a lot of stuff. It already has a working ClearK implementation, so it saves some time. Yeah, so all you really have to do with this is there is some C++ headers included in Firefox or Chrome source code if you want to look at that. If you look around in there. Also, when you run Firefox or Chrome, it will download some blob library and it will put it on your hard drive somewhere. So if you can find that library and you can see and you know the API of the CDM, you can wrap it up in a good simple way of loading stuff at runtime. If you're worried about like portability and stuff, there's Gmodule and glib. It works pretty simply. And like I said before, the application doesn't. The application setup is not any different with like basically your application setup is it's kind of generic for any CDM, especially if you're using especially if you're relying on OpenCDM in general. Like it's not going to have to be too different. The only thing really different is how to talk to the license server. That's going to be specific to every single application. Let's see. Yeah, so the next thing I'll talk about is the development challenges, like what was actually difficult in these two processes. So the first thing was actually porting from WebKit. WebKit is like a very big code base if you haven't seen it before. So just kind of figuring out what's going on in WebKit, how to use it, that's its own challenge. Next thing is once you find out what code you need, how do you remove all the stuff? WebKit has a lot of concepts that come from basically web browsers. So like elements, DOM elements, JavaScript stuff. You basically have to get that all out if you want to get into GStreamer. So that was a fair amount of work. Next thing is WebKit also has a lot of threading stuff because it's like it's a multi-processing model. So you have to figure out how to do that. Another thing, WebKit has multiple backends for the MSE. So code's in a bunch of different places due to the design. So there's part that's GStreamer, part for other media frameworks, I guess like different platforms. So this allows you to simplify the design a little bit. Like before, I mentioned that it basically uses app source, parsebin, and AppSync. The WebKit implementation is more complicated for another reason as well, that it has to deal with old formats. Old installations of GStreamer also, so you don't have those cool new tools. So it's more complicated. Another challenge, which actually I haven't solved it, is how do you actually judge how good this implementation is? Because there is an existing set of test cases, called web platform tests, that basically tests all the web technologies. But the problem is you need a web browser to do it. So we got rid of a web browser, and now you have to put one back in somehow to actually figure out how conformant this implementation is. So that's actually something I'm working on. I'm going to try to figure that out. Yeah. So how much time do I have? Anyone know? I'll see. 10 minutes? Oh, that's pretty good. Okay. I'm pretty close to the end. Okay. All right. All right. All right. How about EME? What did I run into here? EME the EME itself is more straightforward, mainly because it isn't much. It's just interfaces. So the API itself not too complicated to define. To implement it it's a lot of kind of like a mechanical work, dealing with the GST structures, using the GST promise properly, that kind of stuff. That's kind of like tedious when you're working in C, but I'm sure everyone's dealt with that. Maybe if we implemented in Rust, it would be a little easier. I don't know. The next thing is actually a little bit more complicated. When you're writing a decryptor element, how do you know what the element can decrypt? Like what schemes the element can decrypt? If you have a CDM that can do only one format, it's going to be easy. If you have a CDM like the OpenCDM plugin, you don't know because it's an open world. It depends on all the libraries that are installed in the system. So the problem is GStreamer elements. They need to declare beforehand what they can decode. So there's a little bit of a mismatch there. In the decryptor element for the OpenCDM plugin I implemented, I actually I kind of like took all the well-known CDMs, stuck them in there, and then as you start it up, it pokes around and tries to figure out what actually exists on your system. That kind of works, but then you run into the issue of there's actually a registry cache. So let's say 5 minutes from now you delete one of them. It might still be in the registry cache, so then you have to clear out the registry cache. So it's a little bit weird, but this is only an issue if you don't know all the encryption systems that your plugin will support. Otherwise, it's not really that complicated. Yep. Let's see. Development status is for the MSE library. I actually have a merge request open. EME, I'm nearly there. I should have one out soon. Don't know when that will be, but it should be pretty quick. Yeah, the next thing we can do is actually show a little demo. So what we're going to have here is, so there is a media player for web applications. Shaka player I mentioned earlier. It has a big test suite from. I think it's like a Google-sponsored project or a Google-owned project. They have a test suite or test suite, however you want to pronounce that. That has like some encrypted media. And there's some demo stuff. So this demo is actually going to show decrypting widevine content using GStreamer and nothing but GStreamer and the widevine blob and the EME library from a Dash manifest. So let's see if this works. It should be some Star Trek stuff. That's just the demo that exists. Yeah, this is encrypted media using widevine, playing back using GST play with the EME API. So that's basically the EME stuff. Yeah, not sure how interesting this is. Oh, level 3. Good question. Yeah. Oh yeah, I'm actually ready for questions now. So, yeah, that's basically the demo, and that's the conclusion of this presentation as well. So yeah, so we can go to questions if you want. Yeah. Any other questions? Oh yeah, you asked if it was a level 3. This is level 3 because I don't. To be honest, I don't have access to any of the other ones because I just downloaded it. Yeah. So, sure. Yeah, you can ask.
So one of the slides you mentioned, you had to monitor the bus for EME encrypted messages. So those are custom messages or what?
Yeah, it's a good question. These are custom messages, and there's some utility code in there that helps you basically unpack them because all these things that deal with GST structures, like why do you have to? It's like all this data that you don't want to deal with. Yeah, so there's utility code to handle that stuff. Yeah.
Does the decryptor will necessarily have to be an element, or could it be like a metadata that you pass to the decoder to be used, or did you start working on that, or it's still in design?
Well, yeah, that's a good question. I don't really, so I haven't taken the approach that you've taken, but I don't see why not. Like we'd have to like look at the design a little bit, but.
My main concern, the thing I would like to see looked at while designing this is basically a look at how the stateless decoder works Usually they will work on the encrypted codec data till the very, very last step of asking the hardware to decode it, because that's the only place where you can actually see the slice headers. After that, on L1, as an example, the decrypted content is on a protected memory, which is not visible by your CPU anymore, so it's not possible to use it. So, and the assembly of the actual bit stream that you're going to decrypt only happens in the decoder. It does not happen in the pipeline. So that's kind of an exception to pipelining things.
Yeah.
But I'd like to discuss this maybe during the Hackfest. And
For sure, yeah.
So I can give you insights on proper SVP implementation I got that I've been working on.
Okay, cool, yeah, sounds good. Yeah, anything else?
Okay, so you said that that the GStreamer MSE integration does not need a browser library, but does it integrate somehow into into some existing browser, like using JavaScript or something?
Yes, that's a good question. Yeah. So there's currently that's the goal, basically, to be able to wrap the data model of GStreamer into some JavaScript library. I haven't done that yet, but that's actually what I'm going to get around to, because I have to do the conformance testing. So that's basically it's planned. And like one thing you could do, taking it a little further, is if you ever wanted to get rid of the MSE implementation in some other browser, you could maybe take advantage of it in the future. Anything else? I think we're good.
We're out of just one sentence. No, the thing is, if with that other browser you are thinking on WebKit, the problem with WebKit adopting this implementation is that we rely on a lot of multi-platform based classes that need to be shared with many other ports.
Yeah.
And the thing is that we basically cannot do whatever we want. We need to conform to those frameworks and to those APIs and the things. So it would be very difficult for us to reuse this implementation.
Yeah, for sure.
It's impossible.
It's true. I'm just saying, like, in general, writing a new web browser, something like that. All right. I guess that's it. All right. Thanks, everyone.